The executive biometric security system consists of a panel, which is to the left, and a scaled-down version of a lavatory, which is to the right.
Here on the left, we have 4 batteries in series that add up to 6 volts. These are being used to power the driver array. On the right, we have a 9 volt square battery. As you can see, it's being used to power the microcontroller. The Arduino Mega 2560 microcontroller is in the center of our panel. The fingerprint scanner is located on the right side of the microcontroller. The voice recognition module is on the left side of the microcontroller. As we move up, the 2 channels are connected to the driver array and 1 channel is grounded. The microcontroller is used to ground the driver array. Along with the 2 signal lines going to the driver array, we have 3 signal lines going to a 3 output RGB LED. From this angle, you can see the output signal lines from the driver array being sent to a buzzer and the solenoid. Here we have the scaled down version of a laboratory or a vault. This is the inside of a safe, and here is a demonstration of the solenoid being actuated, therefore unlocking the door. To begin, the user will open the panel. The blue steady LED signifies the sensor is ready for input. The first step, the user will swipe their finger. The blinking blue LED indicates the data being matched. The user will say their name and the blinking LED signifies the authentication process. The steady LED notifies the user to say their password. Again, the blinking LED signifies the authentication process. The green LED signifies both authentication process were passed. This will activate the buzzer, green LED, and the solenoid, which will unlock the door. Finally, the user opens the door and is left unlocked until the green LED turns off and the blue LED is lit up. Here we try to open the door once the blue LED is illuminated.
Here, we will demonstrate a false match. And now we have the sensors. First up, the fingerprint scanner. The fingerprint scanner communicates through its serial port to the microcontroller by sending command packets in hex. Here is the GUI for the fingerprint scanner. This allows us to enroll, match, and delete the user's fingerprint that is stored in a database. Now, moving on to the voice recognition module. The voice recognition module also communicates through its serial port to the microcontroller by sending command packets in hex. Coming up next, we have the GUI for the voice recognition module. This will demonstrate a false word match, training, and testing. Debray. EBMS. EBMS. Sorry for the brain. EBMS.
Okay, so it's not trained.
Carla. Carla. Carla.